Hello amazing people, welcome back to my YouTube channel. I am Aryan Kumar and today I am going to teach you all about stoichiometry again. Today's topic is limiting reactant as we are going through our first ever chapter of chemistry's book class 11. This is our major topic of our first chapter. Let's go through it. Now if you can assume the word limiting reactant, so according to your mind you can simply say where the reactant is getting limited is called limiting reactant. Yes, you are right. Now let's build up your concept with an perfect example. Now suppose you are having 8 slices of bread right here and 3 burger patties, or you can say simply 3 kebabs. You can utilize 2 bread and make one sandwich out of it. Meanwhile, you can add only one patty in a sandwich. So therefore you can only make 3 sandwiches among the given product and reactant. Right? This is our reactant, this is our product. Now whatever get consumed at first is known as our limiting reactant, such as we are having 8 slices of bread, we can utilize 6 for making 3 sandwiches because we are having only 3 kebabs, right? I have added one kebab to it, second to it, and third to it. So we'll be having left out 2 pieces of bread and other things will be consumed. So the first thing to get consumed was burger patties or kebab, you can say. So this is our limiting reactant and this is our product. That is how you figure out what is your limiting reactant in a chemical equation, in a balanced chemical equation, and other terminologies where you will solve a lot of numericals, right? So that's how we verify our first ever prospect. The second is you will be having low product always. As we are having low product right here, high reactant, you can simply understand that this is our product by seeing its low amount of value. Okay, at third we are having the process stops whenever the product gets consumed. Okay, as right here happened, same is prescribed here, so you can take an idea. Okay, now if you go through a definition, the definition says the reactant which consumes first gives least amount of product and stops chemical reaction is known as limiting reactant. Example of water is also given here. For example, 2H2 plus O2 gives us H2O, that is water, according to balanced chemical equation. This is balanced chemical equation. If I will remove these, this won't be balanced enough. Okay, so right here we are having 2 hydrogens that are being completely utilized. Meanwhile, only 3 O2 are being utilized at the end, right? Not the two ones, not their exponents, right? So the thing that consumed first is 2H2, hydrogen. So this is our limiting reactant. That is how you understand the process of limiting reactant, how to find it. Okay, so I hope this is clear to you, the process of limiting reactant in chemical equation according to the example of sandwiches. It is pretty easy right now for you to utilize and utilize it at a lot of prospects such as numericals, chemical equation, balanced chemical equation, and etc. Okay, so the thing right here that we have to cover is a numerical. Now this is example 1.15 from our book, whereas it gives us a mass of ethane, that is C2H4 equals to 2.8 gram. Now I'm simply writing data here. Okay, mass of O2, that is 6.4 gram. Okay, mass of carbon dioxide that we have to find, of course, and LR equals to limiting reactant. Sorry for my tongue slipped right here. Okay, again. Now this is our equation. Let me just do it. Okay, this is our equation, C2H4 plus 3O2, again that is making 2CO2 carbon dioxide plus 2H2O. This is our balanced chemical equation, whereas you will solve it out. First we'll convert mass of both reactants into moles. Now we'll convert mass of both reactants, oxygen and ethane, to moles, right? These are masses. We will use formula of it. What is formula? Again, moles of C2H4 equals to 2.8, that are moles per molecular mass, and molecular mass of ethane is 28. Okay, so that will simply give us 0.1 moles of it. Meanwhile, the answer for O2 will be 0.2 as per the formula. Again, the molecular formula for it will be, not formula, molecular mass for it will be 32, and its given value is 6.5. So the formula is moles equals to given mass upon molecular mass. Okay, so you can remember it by utilizing it again and again, practicing it out. That's how you remember formulas. Now, mole of ethane gives 2 mole of carbon dioxide. Mole of ethane gives 2 moles of carbon dioxide as per the valence chemical equation. Okay, so we'll simply multiply it by 2. Our given mass that was converted into mass, moles. Okay, so this is our answer of mole of carbon dioxide now. Okay, now we are having moles of C2H4, that is ethane, of carbon dioxide, of oxygen, both of them. Now we have to find our limiting reactant. Before doing that, mole combination of C2 and H2, not H2, CO2 and O2. Okay, now 3 moles of O2 as per the equation, and we'll multiply it by 2 as per the equation, right? You can consider it as A multiplied by C and B multiplied by D. Oh, wait, I was wrong. A multiplied by C, again B multiplied by C. That is how you utilize it. Alright, we did the process. We had our numbers. 0, O2 is our limiting reactant right here. Okay, so now mass of CO2, carbon dioxide, we'll utilize a formula of mass. Mass equals to mole multiplied by molecular mass. Again, we'll utilize the given value, multiply the actual molecular mass, that is 44. Carbon is having 4, I guess, so O2 is having 32. Not 4, it is having 12. 32 plus 12, it's 44. And here's our answer. I guess that's appropriate for you. That was how the numerical example works, and that is what we prescribed is a limiting reactant, right? So we found our moles right here. We converted masses into mole. Again, we applied formula of mass at the end for finding moles of uh, the given O2, and of course limiting reactant. That's it for today. I hope you liked the video, you understood the numerical, the concept. That's it for today. Bye bye, sayonara.